Each month, I welcome a different guest from the engineering community. Today, I'm chatting with Millie Bigler. Millie is a mechanical designer who engineers heating and cooling systems. Millie, welcome. Thank you for joining us today.
Thank you. Hello. Thanks for having me.
Yeah, I'm going to kick things off by asking Millie a few questions to get to know a little bit more about her, right? You can ask questions too by typing in your questions in the Q&A box below, and we'll save time to answer as many as we can. Okay, so let's get started. So, Millie, can you please tell us about your role as a mechanical designer at FSB Architects plus Engineers Company where you work at?
Yeah, so I'm a mechanical designer. FSB is a company that, in simple terms, we design buildings. So we have architects and then all kinds of engineers. I specifically am a mechanical designer, and I work on heating and ventilation, or HVAC, which is heating, ventilation, and air conditioning systems. And so everything it takes to heat and cool a building.
Yeah, that sounds super cool about
Boy,
your.
hush.
So, what types of heating and cooling systems do you work on? I think you might be muted, Millie.
Oh, sorry. So I work on commercial buildings, and so that's all kinds of different buildings from large commercial buildings like office buildings. We work on things like schools, hospitality type stuff, uh, casinos, hotels, just all kinds of different buildings. Like we don't really do houses, but we do basically everything else.
That sounds super interesting. If you get to work at like hotels and stuff like that, that sounds super cool. So, what does a typical day at work look like for you?
Yeah, so most of my time is spent in the office designing, and so we have all kinds of different programs we do on our computer that help us calculate everything we need to calculate, as well as select whatever we need to select. And then occasionally we do. I apologize for my dog in the background. Sorry.
No problem.
Um, and then uh, and then occasionally we also go out to the job site. So we spend all the time designing all the way through. And then once we're done designing, we'll oversee construction from a very high level point. And so if there's any questions that come up during construction, if stuff wasn't quite coordinated right, sometimes we'll go out to the site just to make sure that everything gets built the way it's supposed to get built. And then at the end of the project, once the building is built, we'll do a final walkthrough, make sure that everything looks right, make sure that everything looks like it got built right and that everything's working. So like we'll test as much as we can, make sure that everything's running right, the building is properly heated and cooled, make sure that nothing's like making weird noises, just stuff like that.
Oh wow, that's again super interesting work. So, what other types of engineers, technicians, and other roles do you work with?
Yeah, so in our firm, we also have structural engineers, we have electrical engineers, we have fire protection, civil engineers, and think that's all of them. So throughout the whole project, we work with them to make sure that everything gets coordinated. Each of them will do their own part of the building. So of course, structural does like all the walls, all the columns, everything to make the building stand up. Electrical make sure everything's powered. Mechanical, we work very closely with electrical a lot because they have to power. We have a lot of equipment that needs to be powered, and so we have to work with them to make sure everything gets powered. Electrical equipment also gives off heat when it works, and so we have to also coordinate with them to make sure that like what do you have that's like producing heat in a room to make sure that we cool that room properly. Civil we don't work with quite as much just because they're mostly like outside of the building, and so they'll do the site, the parking, stuff that mechanical doesn't directly affect very much. Um, and so yeah, just working with all of them, and as well as the architects as well.
Wow, yeah, that's you guys work with almost everybody. That's super interesting.
Yeah.
So it looks like we have a Q&A from the audience. A sixth grader science class in Florida wants to know what the most challenging project you have worked on.
Yeah, so I think one of the most challenging projects I've worked on was the headquarters for the Choctaw Nation. And so at my firm specifically, I work with a lot of tribal projects. And that project was really cool, but also really challenging because it was probably, I think, the biggest project I've ever done. It was a 5-story building, 500,000 square feet,
Wow.
which is just massive. And then we also had, for our heating systems, we did it with hydronic water. And so there was a lot of piping throughout the whole building, just trying to coordinate all of that everywhere. And it was one of my first like really big like projects that I worked on. And so that was really cool. And it was really challenging, but really fun and really cool to see the final product once it was built.
Yeah, I can imagine. How has your line of work changed with the demand of sustainability?
Yeah, so for us, sustainability is actually a really big thing that we think about all the time. In our firm, we actually have a full-time person on staff that he just does sustainability. And so a lot of projects he works with are actually like government projects, but it is something that we have to be conscious of in all of our work because, the effects of global warming and everything, like buildings are a big portion of that because they're a big energy use. And so just making sure that we're keeping up with the latest codes. There's new codes that come out every few years, energy codes, just codes in general. And then also like another big thing that came up recently, or is like a big thing currently is refrigerants. And so there was some new laws that got passed and are right, they got passed several years ago, but they're going into effect now about like what kinds of refrigerants can be used in product in like the equipment that we use. And so trying to keep on top of like what can we use, what can't we use, working with our manufacturers to get the right ones and make sure that we're staying in compliance. And all of that has to do with sustainability and reducing greenhouse gases.
Oh yeah, you're protecting the earth. That's really
Yeah.
good. In from real quick, let me look at the questions. So yeah, do you, in what ways do you think your job encourages you to be a change maker?
Yeah, and so I think just staying on top of sustainability, you know, another thing for me is being a minority woman is a big thing. I've seen the diversity of our engineering field um, change a lot over the last, just since I've been working at my firm for 10 years now. It's been 10 years since I graduated. And so I think just, continuing to advocate for people that look like me to be in our field.
Perfect. Yeah, we love promoting women in engineering. That's great. I understand that you're a member of ASES, an organization dedicated to advancing Indigenous people in STEM. Can you tell us more about your involvement there?
Yeah, so ACES is the American Indian Science and Engineering Society. It's an organization that I got really involved with in college, and so where I kind of started out with ACES. And so I was president of our club there. I was very involved. It's a great organization. And then now currently I am a professional member. And so just one of the programs that I'm part of with ACES is like a professional mentoring program. And so since I have been in the field 10 years now, partnering up with other women who are just kind of just getting started in the field. And it's really, it's a great program and it's really fun because doesn't really feel like a mentor-mentee relationship. Like it really feels like an equal relationship was really cool just to connect with other women that are also in engineering. And a lot of them are in like other types of engineering or other types of science and math fields, which is really cool. So just getting to learn from all of them.
Yeah, I know in the last episode we talked a lot about networking with other engineers, and again today it's bringing up. So for those people watching that, you guys saw in these two episodes, that networking aspect is very important. To go out into and talk to different engineers, and even doesn't need to be engineers who are professional. It can maybe be collegiate level students or high school students even who are pursuing engineering if you're in middle school and elementary. So yeah, so that networking is very important. So, what strengths do you have that make you a good engineer?
I think a big thing for me is to always ask questions, which I think is really important, because you can't learn unless you ask questions, and not being afraid to speak up for yourself and speak up when you don't know something, then learn from others is a big thing for me.
Yeah, of course. Do you have any mentors who inspired you to pursue the path you're on today?
Yeah, so as far as inspiring me to become an engineer, I would probably say one of my teachers in high school was kind of really instrumental in that. And so in 10th grade, I started and we had some like pre-engineering type classes. And it was a teacher at our school that kind of like started the whole program. Because when I was in school, like the push for STEM wasn't as big as it is today. Like I didn't know what engineering was. And so because of that teacher encouraging, they brought in all the students who were like either in advanced math or advanced science classes and like kind of like sold them on this program like, hey, here's like what we're gonna do, like here's like an opportunity to do this. And to me it just sounded really cool. So I'm very thankful of that teacher because of that. I found engineering and I was like, hey, I really like this. This is something that I think I actually want to do as a career, which I think was really cool.
Yeah, that's really cool how that teacher was able to impact your career path, right? So in thinking of the students joining us today and in the future students, what is one piece of advice that you would give to your younger self?
I think just being open to new opportunities and not being afraid of um, trying something new. Like I said, with the engineering program, like I didn't know anything about it, and I was also the only girl in that class. And so that was a little bit scary, but then also like, I just kept forging ahead and learned more, and then it's become a whole career, which is really exciting.
Yeah. What is when you were in middle school, what did you want to be when you grew up?
So when I was in middle school, I actually wanted to be a doctor. And I think a lot of that stemmed from just being really interested in science. And back then, like I was interested in science, so like, oh, maybe I should be a doctor. But then I found out that I really don't like blood and I really don't like broken bones and stuff like that. And so I was like, oh, maybe that's not a feasible career for me. And then thankfully I found engineering, so I didn't have to deal with blood and
Yeah.
stuff I don't like.
What is one skill that technicians and engineers of the future should develop?
I think communication is a big thing. In my role, collaboration is a really big thing because like I mentioned, I have to collaborate with all of the other disciplines to make sure that my design works with them. Like I could have a great design, but if it doesn't work with everybody else, like that's not going to work. And so just being able to communicate with others is really important.
Yeah, I've seen that a lot here at my high school that the communication is very key, right? Like if maybe you work on a project and you're not able to communicate what you're doing, that person on your team isn't able to really help you or really, work together, right? So again, guys, the communication is really, really, really important. When what is sorry, let me yeah. What would you tell kids who maybe think that they're not cut out to pursue engineering or are looking at alternative pathways to STEM?
I would say just don't let other people make you doubt yourself. And just there are a lot of different careers. So maybe if one isn't working out, there's a lot of different types of engineering, a lot of different types of, STEM fields. So for me, I was really bad at chemistry in school. So I found a degree path that didn't need very much chemistry, which is mechanical engineering. And I think to me, like, it's okay that I'm not that great at chemistry because I don't have to use it. And so that was a little bit discouraging at the time, but like I said, if there's like one specific thing that you're not so great at, maybe just like look and see what other options there are, like maybe other types of engineering.
Yeah, I'm not gonna lie with you. I'm not that great at chemistry either. I'm on the same path as you. I'm currently taking chemistry and it's just like it doesn't stick to me. I don't know why. So
Yeah.
yeah, definitely there are a lot of pathways to maybe a class that you don't like chemistry, like what you were saying with mechanical engineering. So it looks like we have a Q&A from the audience from a class in Texas. Can you tell us about a time you failed at something and you learned from it?
Um, yeah, so on projects, sometimes there's stuff that comes up that like things go wrong or whatever. And I've had that come up on a few projects where I either overlooked something or I thought I had like put something in a on our documents that didn't quite make it. So I think just what I learned from it was learning how to take responsibility and find ways to fix the problem and being open, not like trying to be defensive and say like, oh, that's your fault, not mine or whatever. Just to find a way to fix the problem and to move forward and for us to find the best way to make the client, get the product that they want.
Yeah, find those alternative pathways to get the solution that you want. Definitely. Great response. I understand you have your own line of indigenous fashion. Wow. Can you tell us about your business and how your passion for this began?
Yeah, so I have been sewing since I was little. And then about probably 5 or 6 years ago, I started sewing more like, I guess what most people would consider like fashion type stuff. And so I just got really into it. Like I started out sewing for my family, and then I started like doing a few fashion shows and stuff, which was really fun. And I think it's just really cool to like blend like some of our like traditional type designs with, like newer, more modern designs, which is really cool.
Yeah, sounds super interesting. Next question is a fill in the blank, right? I am a blank. Finish a sentence with a word to describe yourself. And why did you choose this word?
I think I would say I'm an Indigenous woman because that's who I am first and foremost is a woman that is part of I'm Yuchi and Menominee as are my tribes, and so I would say that's who I am.
Wow, okay, perfect. Thank you. What else do you like to do for fun outside of your work?
So for me, of course, sewing, it's just a lot of fun. I enjoy that, and then I also have a family, so I have a daughter who's 5, so I like to spend time with her and do fun things with her.
Perfect, yeah. If you could have any superpower, what would you choose and why?
I think a superpower would be able to read something and remember it forever. I think would be a really cool superpower because then you could learn a lot of stuff and sometimes that's for me that's kind of hard is like retaining information quickly. And so I think that'd be really cool. Just read it and then remember it forever.
Definitely, yeah. I wish I could have that superpower too, because if we were on the same boat, we both struggle with similar things. Chemistry. I also struggle with like being able to read something and then retaining it. So I have to read it like
Yeah.
a couple times. So yeah, definitely. I wish I had that superpower too. What is one skill that you haven't quite mastered yet, but you would definitely want to master?
Ooh, that's a tough one. Um, I think
You mastered
outside of
everything.
yeah,
You
outside
mastered
of
everything.
engineering, I think art, like painting and drawing would be really cool. That's something that I'm not good at, but I think it'd be really cool to be good at that.
Yeah. Okay. What is one future trend in the world of HVAC design or mechanical engineering that excites you?
I think this, for me, that comes back to sustainability again. And so, um, finding new ways or the best ways to make equipment really sustainable and make your systems really sustainable, because that's not only good for the environment, but having more efficient equipment can also mean like less equipment, which overall can be hopefully less expensive for the client. And just like, I want to protect the environment and build things that are, you know, not going to hurt the environment in the long term.
Yeah, definitely. We only have one Earth and we have to keep it, right?
Yeah, for sure.
So, what changes would you like to see in the field of STEM today, tomorrow, and the future?
I think there's been a trend of having more diversity in STEM, and I'd just love to see that continue. When I started at my job in my department, I was the only girl. Now I'm one of 3, so that's exciting because it's there's becoming more women in engineering, and just more minorities as well. And I think that'd be really cool to just continue to see the field diversify because I know that we're smart enough. We're to do this. It's just getting people interested in it when they're younger.
Yeah. So it looks like this is the last question of the day. From your experience as an engineer, what is the most surprising piece of knowledge that you think that not a lot of people may know?
Yeah, so I would say for HVAC specifically, something that is kind of funny and also fun is the way that it's depicted in movies. And so if you think of like spy movies or something when they're like crawling up through the ductwork, um, that's very unrealistic because usually like they're in like this big giant piece of ductwork that's like pristine and clean and also supports them. But in reality, those duct that connect to rooms are usually fairly small, like 12 inches at most. There's going to be fasteners in them, so there's going to be like nails sticking into the ductwork. So like when you're calling, that would like you know, like scratch you and stuff like that. And then also it probably wouldn't actually hold you up because the hangers that they use are, of course, strong enough and rated to hold up the weight of the ductwork, but not the weight of a person crawling through it. And then kind of in the same way, like for fire protection, in movies they'll pull the fire alarm and all the sprinklers go off. Like in reality, that's not how it works. The sprinklers have like a meltable little fuse in them, and so when the fire, like something's on fire, the room heats up, it melts that fuse, and that's what sets off the fire sprinkler, not pulling the alarm. So I think I
Wow.
always laugh at that in movies. I'm like, that's not real.
Yeah, I'm not gonna lie, I thought it was like that too, that you pull the fire alarm and then the sprinklers start
Yeah.
dropping water. Wow. I mean, you learn something every day. So, well, I believe that's all the questions that we have time for on this episode. Thank you, Miley, for joining us today. I learned a lot.
Yeah,
And
thank you for having me. I was really excited to get to chat with everyone today.
yeah, I was too. Very, very good talk. We also want to thank ASES for partnering with us today on today's episode. And we want to thank our chat sponsor, the United Engineering Foundation. Also, a huge thanks to all of you for tuning in. To learn more about engineering careers, go to Discover E's website at discover.e.org. Again, it's discover.e.org. And be sure to join us on our next chat with Changemakers on Thursday, November 14th at 1 p.m. Eastern, when we will talk with a technician at Shell. See you then, everybody. Bye.